So we just saw how to improve a little element of optimization in our app just by applying a database index. Now we want to go to the next level. We want to avoid doing unnecessary requests. As we were saying on the last session, this view here is, well, we have two database queries that happen that are not necessarily needed. One is on every request, on every time that one person goes to our page, we're hitting the database to go and grab the keywords, and then we're hitting it again to go and count how many tweets match that keyword. But we know that this number is not going to change, at least in our current application. It's not changing that often. It's just changing when we trigger the process to go and grab new tweets, and that only happens once every 10 minutes on our scheduler. So knowing that, knowing the fact that that information changes only once every 10 minutes, because that's when we're running the scheduler, we could grab this information and store it on a cache and keep it there for 10 minutes. Then when the 10 minutes pass, we can expire that cache and load it again from the database. That way, if we get 1,000 visits in 1 minute, only one of those is going to go to the database, and then the rest are going to read it from the cache. The cache is always faster than going to the database. And with Rails, implementing a cache is pretty easy. If we check Ruby on Rails caching, you can see the documentation about it, and there are many options for caching. What you need to know is that on previous versions of Rails, there was this page caching method and action caching. Those two have been removed, but those are available as gems if you want to use them. Maybe we'll get into some detail there, but I'm gonna teach you how to do fragment caching right now, because that is the specific feature we need at this point. As I mentioned before, we just want to save this in a temporary place on a cache, so we don't have to go to the database and run this tweet count every time. So by caching this complete block, all of it, we're gonna save. Instead of doing this loop through Ruby and going and reading the database, we'll just go and read it from the cache store. It's like it was a static file, and that's going to be way faster. So to do that, we use Fragment Cache. If you see on this documentation, Fragment Cache is pretty simple. Whatever you want to store on the cache, you just wrap it on a cache block, and that's going to save it. And if your first request comes and there is nothing stored on the cache, it's going to run the actual code and store the result on the cache. And when following requests come in and the cache finds something stored on its storage, it's going to serve that instead of going through your code, and that's going to be faster. The syntax has a lot of options. The one I like to use is this one, where you can assign a name to the block. In this case, we could wrap our section of code here. Let's say I want to save the whole table. So I'm going to put this block here and close it here. So I'm saving the complete table, and I can call it, this is all of our keywords. So I can put like keyword home. So I'm going to store all of our keywords home table on cache. Now I haven't configured any caching, so I'm just doing this because as an example. I'm gonna leave it here because we will configure it, but this would take care of everything. Now we have to enable caching, and then we have to define where we want to save this cache. So that's the next step. If you go back here to the documentation, what you have to do is you have to enable perform caching on the config action controller. This is on your environment. So we can go and enable it on production. That's where we want to set it up on Heroku. So let's open up our production environment and let's search for this variable. It should be somewhere here. Okay, so it has the perform caching on true. That's great. And the next step, we need to find how to set up caching on Heroku. So if you go to Heroku add-ons, the one I like to use, well, I see it here, is Memcachier. Let's find it, Memcachier. There are many providers for Memcached, but I have a lot of experience using this one. I like it a lot, and they have a free tier that gives you up to 25 megabytes of storage. In our case, we're going to be saving probably less than a kilobyte, so this is going to work pretty, it's going to be enough for us. So let's add it. Heroku adds Memcachier on here. So Heroku add-ons add Memcachier. Okay, I'm on the free tier and let's open up the documentation. Great, so as always, let's just follow the documentation. Let's go to Rails. Okay, here we have the first thing we need to do is add two gems, the Memcachier and DALI gem. Memcachier gem helps us configure Memcache, and DALI is our interface that Rails uses to communicate with the provider. So let's add them here. Next step, do the bundle install. Okay, bundle install. Okay, that's done. Next step, now we have to configure the DALI store. This is something that you can find also on the documentation here for caching. You have the helpers, that's the Fragment Caching helper we used, but you also have your cache stores. You can define where to store your cache. So you can store it on memory, for example. You can store it on a file. And you can store, this is the file store. On Heroku, this doesn't work for us because remember, the file system is read-only, and whenever we provision new dynos, this comes empty. So we need the Memcached store. With Memcached store, we can give it a provider, and we can set the servers for the provider and everything there. Or we can use this gem that we see on the documentation for Memcached, which is DALI. DALI store, what it does is it tells Heroku, it gives Heroku the functions to read and write from the cache and connects it to Memcache servers. So let's go and add this to our production environment. Okay, let's see if we have cache store already defined. Sorry, find cache store. Here it is. It's commented as Memcached store, so here we'll put just use DALI store. And that's it. That should configure. If we are not using the Memcachier gem, if we don't use that, we have to add this line that specifies Heroku that it should connect to the env variables for your Memcache server, username and password, but we're not using this right now. Okay, we have the gem installed, so it should work right off the bat. So we have the configuration for Memcachier done. We have our add-on configured, so let's reload this page to make sure we have it here. Yeah, we have Memcachier working, and we have the code added to our view here that this should cache all of the result of this table on Memcachier. One thing we need to add here is how often do we want this to be refreshed, right? So we could expire this keyword with fragment expire. Let me go back to the Rails documentation and search for expiring. expire fragment. With expire fragment, we can set the name directly. So let's just go and do this. Let's copy this and put it on the process that we're running on the rake task. So let me go and check. We have that on the keywords model, I think. It's the grab tweets. This one is the one we run on the controller, on the scheduler. This one is the one we run on the scheduler. So once this loop is done, we should go and clear the cache. Okay. So since this finishes here, let's put it there. And then the fragment we want to expire is called keywords home name. So let's expire it there. And that's it. We have all of the elements. We have the gem added to our gem file. We have the production environment set to use DALI store and to use caching with the perform caching. We have our view storing these into keywords cache key, and we have the expiration for this set on the task that goes and grabs new tweets. So whenever it grabs new tweets, it expires that, and the next request that comes to the page is going to generate that and save it on the cache. So this looks great. Let's give it a try. I think I'm running the app here, so let's do a local run first to make sure we didn't break anything. As you noticed, locally we are not using cache. We only added to production. So locally you should see here that it's still running these things. If we wanted to use cache locally, what we should do is set it up, and instead of just production, we should open development here and add perform caching in true. It's false right now, so let's do it true. And let's put a store, cache store. Let's configure it for development as memory. So it's not there, so let's add it. And I'm going to go to the documentation for Rails and find memory store. Okay, I'm gonna set this up as memory store for development. Let's see if this works. I'm gonna restart the server. Now reload the page. Okay, I'm reloading the page and I don't see any errors, so could mean yes. You see, instead of having the queries that we had before, we had this. Now we see that it's reading from a cache item. So you see it here. Cache digest reads it, and it takes 0.1 milliseconds to read. Instead of running all of these queries that were taking 21 milliseconds an active record, it's just taking 0.1 milliseconds and 0 time in active record. So that's the improvement we're doing. This is just locally and it's working. So now let's test it on Heroku. Let's see what we changed on Git. We changed the gem file. We have changes on the keyword, on the view, and the production and development environments. Good. Let's deploy this. Implement Memcached. Git push Heroku master. Great, it finished deploying. So now let's test this page on the internet on Heroku. Let's load it. Okay, so we sent one first request. Let me open up the logs. So we see that the first request, okay, connected already to DALI server. Let me go in exactly where we call that here. So it connected to get the home, connected to DALI, authenticated, and read the fragment. And then here's where since it didn't find it, it wrote the response from that fragment, and we got the result. So if we call it again, we call this page here, and we see the logs, we see that now it just reads from, it reads from DALI, read fragment, and renders. Now it's not writing because it already had it there. And now we have 0 on active record, and the total time spent is 44 milliseconds. Remember, we had this page when we had it optimized, we had it at 2500 milliseconds, like 2.5 seconds. Now it's only 44 milliseconds. And if I reload it again, I can see that on the browser. I can see that improvement here. It's pretty fast. And if I continue to see the logs, it takes 45 milliseconds this time. It took the previous one, this is a show, this is another thing we haven't optimized. So it's 55, but every time it's taking 0 on active record. And instead of that, we're reading from Memcached, and that only takes 13 milliseconds or 23 milliseconds. So let's prove that we have improved a lot of this by running Apache Bench again and send the same amount of traffic that we did before. So we're sending 500 requests with 5 level of concurrency, and let's hit it, and we have our logs here. You see now how it responds pretty fast, and we are serving much more requests per minute, because you see, if I stop it here, it's reading the fragment here, reading the fragment here. Every time it's just reading fragments. It's not going to the database, so it's just taking milliseconds. Just look at this, it's 1 millisecond, 1.4 milliseconds. It's not, as we read more from it, it becomes more efficient also, and it's just taking it through the router, just serving and serving. Our service is just spending 8 milliseconds, 11 milliseconds. It's pretty cool. And again, the great thing of being in Heroku is that we didn't have to set anything. No server configuration for Memcache, no complexity, nothing. And if we want to get more service, like instead of just have one proxy server, and instead of having just 25, we can scale it up to the next paid service. Let's say this one, we have 500 megabytes of space, and we have 2 proxies. This means we have some redundancy. We don't depend just on one Memcache server, we have 2. And if we really grow, we can go up here and just have whatever level we want, depending on the demand we get on our server. Let's check New Relic. Okay, we're running this new process, and let's give it a few minutes again, like we did last time, to see how many requests we're going to be able to serve and how high it can get on throughput. Well, it finished the process now. If you see, the Apache Bench is done. And last time we ran it, remember that the first time it didn't finish. It was taking a long time to process. The second time it finished in a few minutes. But this time it finished pretty fast. The whole test took 20 seconds to finish, because now we are responding pretty fast. We have 25 requests per second we can serve. And remember, last time most of the requests were taking 2.5 to 3 seconds. It was in the 2500 millisecond range. Now most of our requests are getting served, 95% of our requests are getting served under 284 milliseconds, and then the ones that take the longest are taking 441 milliseconds, so less than a second. On New Relic, you see that now when we started running the test, it didn't read almost anything from the database, and we got up to 238 requests per minute. Remember, we had a top, we were topping at 25 requests per minute first without any optimizations. Then we topped at around 100, and now our top is close to 500. And I think we didn't even reach the top. We can get even more requests per minute. I'm going to copy this command here and run it multiple times on different tabs so we can check how many can we get. Let's try to top it up. So I'm gonna run it here, then here, and here, here, and here. I'm sending 1, 2, 3, 4, 5 tabs sending request to our server. So you see that the log is pretty busy serving all of that, but the performance is not degrading. We're always responding on 29 milliseconds, no active record, so it's pretty efficient, I would say. Let's see, this one already finished, this one finished, this one finished, finished, and finished. So we sent all of this traffic already. I'm gonna continue sending it because I want to keep it busy, but you see it's finishing pretty fast. It's taking probably 20 seconds for each of these to get done. So I'm gonna try and send more. Just want to see what the limit is. So now you see how I'm trying to do some load testing, and I'm using just Apache Bench. There are some add-ons that can help us send even more requests to our database, to our application, sorry. So you can test scenarios of having a load of 10,000 users or 20,000 users. So that's the kind of load test we wanted to do once we have optimized our application. So right now with Apache Bench we have enough to test this first level of optimizations, just making sure we have indexes, we have cached, and we have all of that ready. And once we have most of those basics in place, we can start using an add-on to send thousands and thousands of requests. Okay, I think it's finished. This is the log. Continues to work, so I'm still sending some traffic. And let's see on New Relic how many RPMs we get once this is done. Good, here it is. So we got it up to 2,690 requests per minute, 2.69K. So this is a lot for not being like serving any, not working. This is a lot. Considering that we are not using any add-ons or anything, it's just doing Apache Bench, we can stress test a page pretty easily with this. And you see that now the index is responding pretty fast. It's responding at an average of 10 milliseconds every time. If we check the histogram view, you see that now instead of having all of our requests on this extreme, we have most of them on this extreme, on the extreme of less than 10 milliseconds. So we moved from being here on the bad area to being here on the good area. And by now we have implemented optimizations at the level of database indexes, and now we have some caching implemented, and this continues to go up. We're at 3.84K, so almost 4,000 requests per minute. So that's great, 4,000 requests per minute. Let's see how much in seconds. So that's like 66 requests per second. So I would say this page now is pretty optimal, at least the home page. And remember, as the scheduled task runs, it's going to clear that up, expire that fragment, and the next request that comes in is going to again calculate the counts, and we're going to be having the refreshed data on that page. So this is Memcached. If you want to see what goes on your Memcached account, just go to Heroku resources page. Here you have the add-on, and if you click here, you can see the usage of your Memcache account. In our case, we're not using it almost anything, but you see that we're using 0 megabytes. We have 9 connections, that is all of our concurrent processes on Unicorn, and we have 1 item saved. The item is the fragment. So the fragment here, this one, keywords home table, that is the item that we're storing. If I wanna show you an example of another app that uses Memcached. So on this one we have a 1 gigabyte limit. We have 140 live connections, and we're using 281 megabytes of space out of the 1 gigabyte that we have. We have 643,000 items stored, and you can see a graphic here of how much you're using of your Memcache capacity and what's the hit rate, how many times we go to Memcache out of all of the requests that we do. So it's like 60% of the time we're reading from Memcache, and the rest is going direct to the database. In this case, this is a pretty active application, and we're using Memcache on a lot of items on it. But the basic, the core is just this, is understanding how to configure it and understanding where to use it with fragments and other techniques that you can find depending on the framework you're using. If you're using Rails, go to this page and you will see all of the options you have, and you can play around with it. One thing, it's pretty important, go and read this blog post by David, the inventor of Rails. Here's where he explains why they removed page and action caching, and here he explains a preferred technique of how to do caching with Rails now. And here's how he explains how you can do different different fragments and nesting of those. So go ahead and read this blog post, and then it's off to your creativity how to use it. A few hours have gone by since we applied the caching, and one thing I noticed is that these numbers were not changing. I suspected that the expiring process that we added to our rake task was not working, and that was specifically the case. If you remember, we were applying this expire fragment method, and one thing that by looking at the logs I noticed is that we were expiring the fragment every time the scheduler run, but we were using this function from a model, and the function is really meant to be used on a controller. So I searched for the error, I found this issue on Stack Overflow, and here they suggest a solution, which is to use the same method but include the object, the active action controller base, and create a new instance of this, and then call the expire fragment. So that's what I went ahead and did on my code. What I'm doing here is adding this portion to the expiration, and that fixes the problem of clearing the fragment. But if you have followed this through, you will have the issue still that even if this expires the fragment, you are still getting the old data. And that happens because if you see the logs here, I have my log when the scheduler was running, and the method was running okay. It authenticated to the Memcached server here, and it expired the fragment. This happened correctly. But when we call the home page, the fragment it's reading, you see the name here, it says views slash keywords home table, and here we're reading views slash keywords home table, but then it has some extra information. So when we're expiring this one, we're deleting a key that it's actually not the one that's being read. And this is something that was introduced in Rails 4. Again, looking on the problem on Stack Overflow, I found this. Rails 4 expired Fragment Cache is not working, and here you see that the issue was exactly that extra content that the key has. This is called a digest, and you can pass this parameter to the cache block to skip the digest. That way it creates the key just with the information you give it, and it doesn't include that. So I went ahead and updated my index view to create the cache key and skip the digest. I already deployed this, and if you check my logs here, once I deployed it, I'm gonna scroll down to where we use it. Here's where when I did the deployment, and then after we deployed, you'll see when I start reading the fragment, now it reads the fragment without the digest, and it writes it. So after that, every time I load, it starts reading that fragment, and when the scheduler runs, it's going to expire this specific fragment. And that way I was able to fix the issue of these numbers not being updated. So now if I refresh this page, you see how the numbers actually change. Since this process is running every 10 minutes, it clears the cache and then the numbers get updated. So that's the final piece of information I wanted to add to this session, where the fragment expiration was not working. And in summary, what I had to do is call the method, including the action controller, because we're doing this on a model. So we have to do this. And then on the creation of the key, skip the digest, so the names are not going to have those extra characters at the end. So that's it. That's our first Memcache implementation. I'm going to follow up with some load testing techniques and then follow up with more caching for our application.